Hello everyone. So, I haven't been doing much the past couple days because I kind of ran out of parts, but I just got my new shipment in and I started working on the new version of the arm. I kind of took everything that I learned from building the arm the first way, and I figured out all the things that were making it difficult to work on, and that helped me figure out what parts to get. So as you can see, I've modified the linear slide base pretty heavily. The track is still the same, so it's still just that same motor with the running the 2 gears, but the yaw section has been completely redesigned. I got another small turntable bearing because I like these way better than the large turntable bearings. The large turntable bearings they don't integrate well into the rest of the system. They're on a unique gear size, and nothing fits into the standard VEX, the holes, so it's impossible to get gears off of them without going through a huge amount of effort. So I swapped it out for the little turntable bearing. As it happens, with these extra 2 supports here, it's also extremely sturdy. The other one was having problems with bending, so this solves the problem of the bending. And there's also one other very big advantage to this, and that is now instead of having to go here, and here to get the potentiometer keyed into the turntable, now I just have it, boom, right here. And now it has exactly the same arc this moves at exactly the same speed as this. So this just got a huge amount easier to work with. And then I added in these as supports, and originally I was just going to cut them, but then I thought about it and it said, well, hey, we can make these stick out, we can let these stick out onto the end, and that gives me a place to put the Cortex. So as you can see, I've already kind of wound some wires up to those are going to all of the 2 motors and the potentiometer, as well as the encoder for the integrated encoder. And then I'm left with a couple other wires. These ones will be going to the arm, and what I'll probably do is wrap them. I'll point the turret that way, which is about the limit of where I want it to go anyways, and then I'll I'll wrap it around until it can come to the back. Make it turn this way, whatever way is longest, have it wrap around so that when it unwinds, it's giving more slack and it won't run out within its arc. This whole area has been simplified. I've got the Cortex, it's sturdier, so that's an improvement in design. When it came to the arm, it was really cool having the giant arm for a while, and it actually did work. I noticed there was one of my worm gears, and it's hard to see, but this, you probably can't tell, but this this is starting to get scratched up. So that's something we want to avoid. So I was at about the limit of the torque that I could get out of it. So I'm in the process right now of switching over to the small arms. I also did one other thing, and I redesigned the gripper section just a little bit. So before I kind of had, I don't have a spare one. I had one of these L brackets, and it was sticking out like this. So the entire, basically this motor was all the way in line with the pivot, and that meant when the arm was turning, you basically had to lift, you were lifting almost everything. This moved it back by at least a couple inches, and I can already tell the difference just trying to lift this thing by hand. It's way lighter and easier to turn. So that's another significant improvement in making this be able to turn faster. So and then over here I've thrown on 2 limit switches, and the purpose of these, this one is the product detector. So when something is in the gripper arm, this one gets triggered, and that's how it knows that something is actually in there. Because of the way that this is made, this is as far as the gripper arm will close. And that's what this limit switch is for. I've kind of got this arm cammed out so that as this closes, right when it gets to the furthest that it can mechanically go, it trips the limit switch, so that way I'll be able to tell if it's when to stop it before it gets completely closed. I haven't decided if there's a good way to maybe put on a third one to tell where the other mechanical edge is, but if I can and I've got enough room on my ports, I'll look into that. But it's kind of hard to work this and hold the camera at the same time, so you'll get to see that later. And then this is kind of showing where I think the new bearing position is going to be. I'm going to be redoing the gearbox because when you think about this, I've almost cut the arm length in half, and if we remember our formula for torque, torque is equal to force times distance. If you have the distance, you have the amount of torque that's required to lift up the arm. And if I were to keep that gear ratio the same, I would be generating twice as much torque as I need to make the arm move, which I think I can, what I'm hoping to get away with, especially now that I've got more chain and I can actually make this a little bit less convoluted to get these exactly where they need to be. First thing, I'm going to be working in a second worm and wheel for the wrist joint, so that way the wrist joint will have lots and lots of power, or lots of torque to be able to lift up the arm. And then I'm going to try and make it so that I don't need this extra stage of reduction. I want to just be able to run it off of the about 3 times reduction. And I think given that I'm having the torque, that everything should work out just fine with that. But we'll see when I get there.